All right, good morning. My name is Dan Friedman. I'm a data center technical solutions architect. I work for the America's Partner Organization at Cisco. I support partners in the Pacific Northwest. The purpose of this presentation is to provide an introduction to IWO, which stands for Intersight Workload Optimizer. Basically, IWO, you can think of it as a add-on plug-in module that adds functionality to the base Intersight platform, which I covered in a separate presentation called Introduction to Intersight. In that presentation, I walked through the overall product architecture, and that architecture is effectively what allows IWO to reach out to your private cloud infrastructure for the services that it offers. So this presentation is suitable for business and technical audiences, and we're going to go ahead and get started. From an agenda perspective, we're going to talk about why Intersight Workload Optimizer is needed, what it is, and then we'll talk about some priorities in terms of how Workload Optimizer evaluates resources that it's trying to optimize and makes decisions. Then we'll talk about how to basically configure the product in terms of groups and policies, which can be used to help automate a certain amount of the execution of recommendations that IWO provides. We'll do a quick review of IWO Architecture, and we'll wrap it up with some pointers to IWO Resources, which really are the same as Intersight Resources. So, in the Introduction to Intersight presentation, we talk about how Intersight helps customers manage multiple layers of operational complexity and tooling, and that's going to be a theme in this presentation as well. So let's dive into why do we need Intersight Workload Optimizer, and the answer in 3 words is application resource management. So what is application resource management? And the simple answer is it's the simple concept or idea of trying to obtain optimal business application performance at the cheapest possible price. But what is simple in concept is not always simple to achieve or implement. And so we have to ask the question, in this case, why is that difficult to implement? And the answer is because there's challenges, which we highlight quickly here on this slide. These are the things which make a simple concept difficult to achieve, and therefore these are the challenges that Workload Optimizer was created to address. Things like siloed teams, disparate data from the different systems that are involved in providing a platform for the application to run on, fragmented tools, fragmented skill sets. You've got different operators managing different portions of the infrastructure. Just like the next bullet says, multiple layers of administration, lack of event correlation across all of those layers, and this results in disconnected and reactive operations. And I always like to provide a picture because I think this helps illustrate exactly that point. This slide provides a visual summary of what we just said on the previous slide. So on the right, there's a high-level representation of the components that are common to just about any modern-day technology stack when you're building a solution. Starting at the bottom, you have your individual resources, components which are combined into infrastructure for network storage and compute. Above that, you have hypervisors for virtual machines along with their associated operating systems and applications, or container orchestration platforms along with their associated containers and applications. Then on top of that, you have a need for management, visibility, insights, and actions that can be applied to applications across public and private cloud boundaries. The multiple layers of complexity that we discussed on the previous slide are pretty easy to visualize. over on the far right of this slide. On top of that, as we can read on the left, you have siloed teams which are responsible for their specific layer, and you also have disparate data and fragmented tools that also only exist at their specific layer. So on the previous slide, we said that there were multiple layers of administration, lack of event correlation, and as a result, disconnected and reactive operations. I think that's pretty easy to visualize here. Now, if we don't do something about this, then that comes at a cost, which is summarized in the lower left, right? Disconnected and reactive operating model. Things like war rooms resulting from lack of visibility across applications and infrastructure, unnecessary time and cost wasted with multiple platform-specific tools, increasing costs from over-provisioning on-premise and in the cloud, application performance issues that impact user experience and the business, keeping track of and adhering to compliance rules, and underutilized infrastructure resources. All of these are different types of problems that result out of not having a sort of holistic approach to managing the problem of application resource management. At the end of the day, this entire stack is about delivering the applications for the business. So Intersight Workload Optimizer helps customers manage these multiple layers of operational complexity and tooling that result in the challenges with application resource management that we listed on the previous slide. So application resource management requirements change constantly. Every time you add, delete, or change something in your environment, that changes the dynamics of the entire system as a whole. And it really, it's a complex relationship of resources, cost, performance, compliance, really with so much data involved that the problem simply exceeds human scale or capacity to deal with in an effective manner or in a time frame that's meaningful to real-time business application performance. And that is why we need Workload Optimizer to handle the complexity, scale, and automated real-time decision-making for us so that we can drive return on investment out of our infrastructure and business applications. We want to get exactly the performance we need in real time while leveraging existing equipment to the fullest extent possible and without wasting any money. So, do we all agree that this problem is worth solving? Maybe, maybe not. If you're still not convinced, let's go to the next slide and try to illustrate with a simple example. So on this slide, we're not even showing all possible metrics that could be tracked in the multiple layers from the previous slide. We're only focusing on host, data store, and VM metrics that would impact operator decision-making in a relatively small environment. For hosts, these data points might be things like the number of CPU cores, CPU threads, total RAM, total disk, available disk, network utilization, bandwidth, delay, jitter, packet loss, etc. Anything that would impact a host. For data stores, these data points might be things like total raw capacity, formatted capacity, deduplicated capacity, maybe capacity per storage tier if you've got different tiers, estimated capacity expiration date, and so on. And for VMs, these data points are much like the hosts, right? Total vCPUs, total vCPU threads, available vCPUs, total RAM, available RAM, total disk, available disk, network utilization, and so on and so on. So let's throw some numbers at these equations real quick and see what happens. And I'm going to kind of populate all of the blanked out number fields all at once. On the top line, we're showing that we're tracking 20 metrics per host across 10 hosts for a total of 200 metrics on the right. On the middle line, we show that we're tracking 5 metrics per data store across 10 data stores for a total of 50 metrics on the right. And on the bottom line, we show that we're tracking 20 metrics per virtual machine across 90 virtual machines for a total of 1,800 metrics on the right. When we add up all those values on the right, we wind up with the grand total in the bottom right corner of 2,050 metrics. And boom, just like that, your team of 3 operators has over 2,000 metrics that they need to monitor that impact their decision making when you call them and tell them a business application is down or misbehaving. 2,000 metrics which collectively come from a disparate set of tools which must be gathered by operators with different skills, assembled, analyzed, and decided upon, again, in a time frame that is meaningful to real-time business application performance. This is impossible. Right? This is exactly what we mean when we say that the problem is beyond human scale to solve in a reasonable time frame. So now, hopefully, you're convinced that we need the assistance of technology and automation to make successful application resource management a reality. So what is Intersight Workload Optimizer? It is a SaaS-based real-time decision engine. You may have heard of Cisco Workload Optimization Manager, CWOM for short. CWOM is also a real-time decision engine, but it's not SaaS-based like IWO is. It is installed and maintained by the partner or customer. Beyond that, CWOM and IWO have similar capabilities, but CWOM is eventually going to be going away, leaving only IWO behind. I think that that's because the architecture of Intersight allows IWO to be applied both across public and private cloud, just as CWOM does, but it's easier for the customer because there's really nothing for them to install or maintain. There is an install, but it's all automated through intersight.com. So let's see here. A decision engine like IWO needs information or data upon which to base its decisions and therefore the recommendations that it makes. That data can come from an arbitrary number of source locations, platforms, and equipment. Each source is configured within Intersight as a target. So again, if you've seen my Introduction to Intersight presentation, you'll know that configuring a target involves the claim process. With Cisco equipment, that involves a direct connection from a device connector and its associated device ID and claim code. Whereas with third-party equipment, this involves either a direct connection to a public-facing cloud service provider API or an indirect connection to on-premises third-party equipment behind the Intersight Assist appliance, which behaves as basically a reverse proxy. So you claim the Assist appliance in that case and then use it to point at all the third-party equipment that you wish to manage. All of this means that IWO can reach out to and ingest data from many sources, including your cloud service providers, network devices, storage devices, compute devices, hypervisors, even applications. And the more targets that are configured, the more data Workload Optimizer receives, the more information it has upon which to base its decisions, and therefore the smarter it gets, the better, more specific its decisions and recommendations become. So let's have a quick look at some of these supported targets. We have a broad and growing ecosystem of targets that we support across a number of different categories. So we support different applications and application performance management systems, public clouds, compute and container platforms, and storage arrays and hyperconverged compute systems, ranging across a number of vendors that are not just Cisco. Right? So we can ingest data from all of these different sources, and as it says, right, this is a growing ecosystem. So as time goes on, we're going to support even more. All right, so to continue the discussion about what is IWO, IWO is concerned with both your current state and the future state of your environment. The current state is evaluated in real time and with automation enabled, it can make immediate changes to your live environment. The future state is evaluated offline. This is more or less like a mathematical calculation, and so it makes no changes to your live environment. These recommendations or reports or output that you get are strictly based on hypothetical circumstances. So no changes to your live environment. The way that Workload Optimizer internal intelligence analyzes your current state or future state is based on algorithms which model what we refer to as a marketplace. This digital marketplace has equipment providers, or you could say it has equipment for sale. The equipment provided is the supply, right? This is the equipment. If we're talking about on-premise that you have purchased and installed in your data center, and it is now available for consumption, consumption being kind of a high-level concept, right? Eventually having impact directly on a business application. The digital marketplace also has equipment consumers. So that equipment that you've installed, now you consume that equipment by running various operating systems, hypervisors, applications, and stuff on top of it. So the equipment needed by the buyers is the demand, and the equipment provided by the sellers is the supply. So Workload Optimizer's real-time decision engine is therefore based on the concepts of supply and demand, and its intended purpose is to model and determine how best to balance the available supply with both the current and future demand, depending on what you tell IWO you want to do or what targets you configure. And it does this by looking at three critical factors, which we're going to outline in an upcoming slide. Before we do that, though, IWO provides a visual reference to this supply and demand marketplace within its user interface. The more targets that are involved, the larger and more complete this visual reference becomes, because the more supply and demand relationships that can be logically stitched together and visually depicted. This way, the way this really works is IWO queries the API of each of its targets, and it then crunches all of the data that it receives back to determine how each logical component it learns about is related to and connected to and serviced by all the other logical components that it learned about. So it determines the relationships and dependencies between applications, load balancers, virtual machines or containers, network, compute hosts, storage arrays, all of that. Each component in the visual reference is color-coded and clickable in a way that allows the end user to quickly focus on critical areas and drill down to more context-sensitive views. For example, your application may involve dozens of VMs, so the visual reference may show the number 24 next to the VM object, but if you click it, you can see which of the individual VMs have which recommendations. So we're going to go ahead and move over to the next slide and have a quick look at this visual representation. So in the left of this slide, we can see that Workload Optimizer continuously receives and crunches data to solve for the best possible performance, compliance, and cost in that order of priority, and it does this in real time. And then it determines what workload to run where, when, and why. What's the justification for the decision? Now, on the right, we can see under the, well, man, this is really small. I'm going to use my mouse here. So we can see under the, down here, under the Optimize menu, there is an Overview tab, and that brings up this dashboard that you see here on the right, which is it has the visual representation of the marketplace of supply and demand, which is shown here. So, what do we see here? And I realize some of the text is a little hard to read, so I'm going to go ahead and just kind of point out what we're really looking at. So down here at the bottom, we have the internet. The internet is connected to our network, and the network services our data center. Within the data center, we have a number of hosts, which run hypervisors, and we have virtual machines that basically run on those hypervisors. And those virtual machines may have virtual disk for the operating system that's presented as a volume. It is consuming storage, right? Volume is coming from a storage controller, and the storage is pulling actual, it's leveraging actual disk space that's provided by a disk array. You also have the host here directly consuming storage through the controller through to the disk array. So, in that case, maybe the hypervisor is boot from SAN, but for the VM, it's got its virtual disk stored on a VMFS data store, something like that. Or maybe, something like that. Okay, so for each one of these sort of circular icons that you see, there's a number inside of it. In this case, I believe it says 451 virtual machines. Down here under hosts, it says 14 hosts. So you understand the type of object, the count of object, and the colors that you see indicate several different things. So the red indicates a performance problem. That is the top priority, which we're going to discuss, I think, coming up on the next slide. That Workload Optimizer wants to guarantee optimal performance of your business applications so that you've got the best end user experience possible. Yellow color indicates either a compliance or a cost-related problem or optimization that can happen. And green indicates that there are no problems currently. So we can see that in this case that our hosts, out of 14 of them, a certain portion of them, looks like about a quarter of them have recommendations in red, which means the hosts are having some performance problems. And if we were to click right here on host, over on the right side, this would become context sensitive. And the diagram that you see here would really focus on the host, so you might no longer see the virtual machines because you've drilled down to a deeper level of infrastructure. And then over on the right, you'd be able to see the list of hosts and potentially the list of recommendations across the impacted hosts. So, this might indicate overusage of the host with corresponding recommendations. To solve such a problem, Workload Optimizer might recommend migrating VMs from the problem host to another host. Maybe it'll recommend purchasing additional hosts or purchasing additional resources for the existing hosts like CPU, RAM, and disk, and so on. Obviously, like I said, to find out, you click on the host circle, drill down, see a list of recommendations. So something worth noting here is that up at the top of the diagram, or supply chain, is a virtual machine. And what about the business application? Well, Workload Optimizer has a native integration already in place with another product called Application Dynamics, which can provide better visibility and metrics at an application level. So, for example, is the Java heap for your application over-provisioned? If it is, you could downsize your Java heap, giving resources back to the VM. Then you could downsize RAM on the VM, giving resources back to the host. And then the host could then use that RAM to service some other VM. And this is what we mean when we say we want to use IWO to figure out how we can most cost effectively leverage all of the resources that we already have. Another application level example might be something like our SQL calls to your database taking too long. So App Dynamics is a source of application data as shown back on the supported target slide. So if we are running App Dynamics, we can configure that as a target, ingest all that data, and then this visual representation of the marketplace would be extended to include components at the application layer. So Workload Optimizer is always simultaneously, and that's what we're looking at over here on the left, solving for performance, compliance, and cost based on real-time metrics that are constantly changing, evolving, and creating multiple, sometimes contradicting factors that must be balanced to achieve good decision-making. So, again, to repeat, in short, IWO is a real-time decision engine that decides what workload to run, where, when, and why. All right, so let's talk about IWO's priorities and how it evaluates current state and future state. We said that IWO is concerned with both the current state and the future state of your environment. And so on this slide, we're just going to take a deeper look at how each of those things works. So if we talk first about current state, Workload Optimizer uses data from targets, like we've talked about, those are your data sources, as input to its decision engine. And the decision engine is really concerned with three priorities. The first one being performance, specifically application performance or end user experience. These days, the businesses are the applications. If your users have a poor experience with the business application, they are likely to abandon your service and go do their business elsewhere. So performance is absolutely critical to successful business, and that's why it's priority number one for Workload Optimizer as consideration for its decision engine. Next, we have compliance, and this is really about ensuring that any configured business rules or policies that you have configured inside of Workload Optimizer are adhered to. And I think we'll get into a few of those examples a little later. With cost, this is about ensuring the efficient and cost-effective use of available resources. So when we think about private cloud equipment that's installed in your private data center, it's really a sunk cost, right? You've already spent the money. So in this case, it's about deferring the need to purchase additional resources by driving the efficient use of the already purchased resources. In other words, ensuring optimal utilization, right, of existing resources. Now, with public cloud, because that's typically pay as you go, in that case, it's always about minimizing cost. And that requires an understanding of both on-demand versus reserved instances and the pros and cons of each to see why Workload Optimizer is really a relevant solution for the public cloud. Now, if we talk about the future state of your resources, Workload Optimizer allows you to essentially modify the buyer demand side or seller supply side or both part of the market equation or algorithm to simulate a future state which is altered from the current state. So this is basically called future state planning. And in the user interface, you will actually run what's called plan. And this plan is geared at helping you understand whether you'll have enough resources after making changes, and if not, what resources you'll need to procure. So specifically with regards to private cloud, this will help you answer different types of questions. For example, what if I added 3 new hosts or removed 3 new hosts from my compute cluster? How would this impact VM performance, compliance, and cost? Will adding new hosts increase performance or only increase cost? Will all workloads be able to take advantage of new hosts based on current business policy rules that are set up? What will it cost me, and how do I get the biggest return on investment by ensuring healthy utilization of all my hosts? Or what if I moved a VM from host A to host B? Does host B have the capacity for that VM? If not, how much capacity needs to be added to host B, and what will that cost? What will the impact be for other VMs on host B? Will the source VM perform better while the rest suffer? Or what will happen if I want to migrate a bunch of workload to the public cloud? What are the cost estimates of making such a change? So that's more of a public cloud example. Let's move more into that. What would your cost be if you migrated all your VMs to the cloud without making any modifications, versus what would the cost savings be if you first optimized your VMs and then moved them to the cloud? This is something that Workload Optimizer is intelligent enough to understand. Would it be more cost effective for you to bring your own licensing or buy licensing from your cloud service provider when it comes to licensing your operating systems on your public cloud VMs? How can we best leverage reserved instances to manage our costs most effectively? And reserved instances can be hard to manage because, unlike pay-as-you-go resources, these reserved instances you pay for whether you use them or not. So it's more like that sunk cost of private cloud. And in order to make them cost effective, you must use them. So in this way, reserved instances behave kind of like a slot that you can move workload into and out of. And if you manage this well, then you can save a lot of money. But if you don't, it's not really going to result in cost savings. Now, down at the very bottom under future state, it's not just about these hypothetical what-if situations or plans that I mentioned, but you can also create what's called reservations. So imagine if in a month from now you're planning on adding a new business application and it's going to require 20 different VMs in your environment, and you basically want to make sure that the resources for all of those VMs are going to be available. So you can place a reservation inside of Workload Optimizer that essentially pretends that those future VMs have already been deployed and the associated resources have been consumed, so that the decision engine will act accordingly, right? It will act as though that application has actually already been deployed. It won't have any live metrics to collect, but it might make, certain placement decisions either based on policy or resources available on specific hosts. So hopefully this explains quite a bit about what Workload Optimizer values when it's evaluating criteria for the decision engine, making its recommendations, and the types of intelligence that it can bring, the types of decisions that it can help you make. So I guess to summarize, what can you do with IWO? To summarize the slide, right, it basically says that you can make sure that resources are not under-provisioned or over-provisioned, because if they're under-provisioned, you're going to impact performance, and if they're over-provisioned, you're going to waste money, and we don't want to do either of those things. You can leverage it for what-if analysis to understand impacts of planned actions on your environment, primarily in terms of performance and cost. You can use it to automate decision-making to drive high return on investment out of your investments. You can use it to plan workload migrations to the public cloud. You can use it to optimize your spend by spending only what you need to achieve top application performance and premium end user experience without overdoing it. So if I were to use maybe some more marketing terminology or marketing description of the product, IWO leverages artificial intelligence-powered analytics that deliver intelligent insights and actions to ensure application performance and to reduce cost. It does continuous agentless monitoring of cloud provider catalogs and maps workloads to best fit resources. So what that means is if it finds a virtual machine running in, say, Amazon Cloud, and that VM is determined to be over-provisioned, it's aware of the different basically workload sizes, like T2 micro and stuff like that. And it will find a plan that is more cost effective, but still meets the performance requirements of your application. IWO is a single tool with full stack visibility across on-premises and public cloud environments, and it adapts quickly and reduces risk with data-driven capacity planning. So that's all about the data sources and targets that it has. It leverages that information to, again, adapt quickly, reduce risk, make sure that you have enough capacity to service your apps, not just today, but in the future. Finally, the best thing that you could possibly do with IWO is you can use it to pay for itself and then continue reaping the cost savings rewards. So down at the bottom of the slide, I think it makes a great point. You buy IWO for application resource management, but you pay for IWO using the cost savings that it uncovers. You sort of pay yourself back over time and then some. All right. So now we're going to talk just a little bit as we get towards the latter half of this presentation about Workload Optimizer groups and policies. And this has to do with configuring policies in the system, whether or not they're going to be automated, how this all works. So we'll start at the top with the concept of groups. A group is just a collection of resources, and you can either create a static group, which is where the group membership is assigned manually by the operator, or you can create a dynamic group, in which case group membership is determined dynamically according to certain filters that are set up. So if you wanted to create a group of VMs, you could potentially set up a filter to do that based on some sort of naming convention prefix. Maybe there's a filter that you can use to do that based on the installed operating system, or those are just a couple of basic examples. Now, policies provide the administrator with control over how and when the Workload Optimizer decision engines executes upon the recommended actions that it provides. So there's a couple different types of policies. There's placement policies and automation policies. Placement policies determine where a resource should run. And to provide some examples of those types of policies, these are things like affinity or anti-affinity policies or merge policies. So an affinity policy is about keeping two machines on the same host or same cluster, whereas anti-affinity policies are about keeping two machines on different hosts or maybe different clusters. And a merge policy is about combining two resources into the same logical object from a decision engine perspective. So we just mentioned, keeping two machines on different hosts or clusters. What if we had two clusters and we wanted to allow VMs to move between the clusters? Then you could combine those two clusters into basically a merge policy, and that would allow such a thing to happen. Now, when you're creating placement policies, you can also create constraints of the placement based on group membership. So, for example, you can place a specific group of virtual machines which belong to a team only onto a specific group of hosts which belong to the same team. In other words, Team A is not going to run their VMs on hosts that are owned by Team B. So that would be, an example of kind of like an affinity group leveraging group membership on the VMs that would run on a certain group of hosts. Another example is, I'm just going to leave it at that for the placement policies. For automation policies, these are the things that you need to set up inside your IWO config that basically allow IWO to act on behalf of human beings. So IWO is going to make recommendations, and if you don't have automation policies enabled, then the recommendations just kind of sit there awaiting manual interaction from the system operator to go ahead and execute one recommendation at a time. So when you build your automation policies, you can do the same thing. You can have constraints to those automation policies based on group membership and schedule. So, for example, you could allow the dynamic resize up actions automatically for a specific group of VMs only, and only during a pre-approved change window. So in other words, if you've got an application that is in the red and is having performance-related problems, this is typically because the resources on the VM or maybe even the host are under-provisioned. And so we want to, in particular, a dynamic resize up obviously wouldn't be applicable to the physical host, but for a virtual machine, we want to bring that VM down, add CPU, add RAM, etc., boot it back up, and have that all done for us automatically, but only on Saturday at 2 a.m., right? Because that's our pre-approved change window. So you can build policies and rules like that inside Workload Optimizer. So taking all of this together, right? Once Workload Optimizer figures out how everything is connected and it crunches all the data it received with regards to performance and compliance and cost, it makes these recommendations for action. And by default, the system only notifies the operator of those recommendations. The actions must be executed manually through the Workload Optimizer UI by the operator. So for example, to migrate a VM, you would just have to see the recommendation in the UI and click a button manually inside of Workload Optimizer. You don't have to go into vCenter and initiate the migration. Now, however, these same system policies are also configurable to allow actions to be executed automatically by Workload Optimizer itself in real time with the decisions and recommendations that it generated. The way that most customers handle this at the beginning, if they're uncomfortable, is to create groups of equipment and then enable automation on just that group of equipment. So maybe you're just getting started with Workload Optimizer, you're not confident in the decisions that it makes, you want to see them before you execute the recommendations, and maybe you want to only automate your dev test environment, but you want your production environment to be manual execution by an operator. You could totally do something like that. Once your confidence builds and you start seeing the improvements that I was making in your dev test environment, then you're probably going to want to have the policies apply to your entire data center as opposed to just a limited group of equipment. So once confidence builds and automation is enabled for all equipment, this is when Workload Optimizer really shines and starts to provide its maximum return on investment. So just keep in mind, right? It's important to understand that Workload Optimizer is constantly monitoring, updating, and making new recommendations in real time as you add, remove, or change resource usage within your environment. This isn't a problem that it solves and goes away. Like, point in time, you run Workload Optimizer against your production environment, and it makes recommendations, it does all the fixes, and then that's it, right? Because inevitably something is going to change. A host will fail. An application will demand too much CPU from a VM. A new business application is added to the environment, and so on and so on, right? So all of these changes that happen in business each day will be picked up, analyzed automatically by Workload Optimizer. It's always working for you. Okay, so almost to the end here of the presentation. So quick review of IWO Architecture. I mentioned another presentation called Introduction to Intersight, in which I discussed the different methods of deployment along with some architectural enhancements. So the methods of deployment are SaaS-based, Connected Virtual Appliance, or CVA, and Private Virtual Appliance, or PVA. And I'm not going to go over CVA or PVA in this presentation. You can see those in the Introduction to Intersight presentation. But I will say that SaaS is the most preferred because there's nothing for the customer to install or update or maintain or secure. They just create an account and start consuming it. Obviously, different features can be licensed into that platform, but this is the easiest way to get started with Intersight. It also leverages on-prem virtual machine per data center that's installed called the Assist Appliance. And what this allows is you claim the Assist Appliance into Intersight.com, and then that appliance acts as a reverse proxy that allows Intersight to talk to and manage and target third-party equipment, which means that the Assist Appliance, from the perspective of IWO, which again is just a software module that's running out in your SaaS instance of Intersight.com, the assist appliance is what allows that software to reach out to virtually any on-premises location and talk to your third-party equipment. So it can target your vCenter, your Hyper-V, your Kubernetes, your storage, and so on. Okay, so that's really all I'll say here about IWO architecture. Is basically it directly follows Intersight architecture. Also, IWO itself is, as I just mentioned, it's just a software component, right? It is a SaaS component, a module, if you will, that you license and enable and install from within Intersight.com itself. So there's no on-prem VM that you need to deploy. It really kind of comes down to purchasing your license, enabling the license. There is actually, I think, an OVA or virtual machine that gets deployed in the cloud, but that is an entirely automated process that can be handled directly from the Intersight.com UI. All right, so finally, a few resources. These really are not Intersight specific. Actually, the dCloud link here provides an introduction or a demo for Intersight Workload Optimizer. The other two bullet points up at the top, both Intersight.com and Intersight.com/help, I took these links straight out of my other presentation. So you can sign up very easily for an account on Intersight.com. It's free. The base license allows you to claim your UCS or HyperFlex on-premise equipment, and other features have trial licensing, or you can purchase and enable those licenses and then can consume those functionalities. The link to Intersight.com/help, if you visit that link, it's got several sections of information available, including resources, which contains both the Intersight handbook. It's a great read. It talks all about Intersight and all of its different modules and the benefits that they provide, along with user guides for each of those modules, so you can find IWO-specific documentation there. There's also a Getting Started section, talks about features and how those align to different licenses, things like that partners would be most interested in. So that's all I had for introduction to Intersight Workload Optimizer. I hope this was valuable. If you have any questions, feel free to reach out to me. Again, my name is Dan, and I'm a Data Center TSA. Thanks for listening.